Welcome to Online Maths TV. My name is Jakes Anemo, and in today's challenge, we want to look at the laws of logarithms, the foundation, the pillars that actually hold logarithm in place, the rules that governs the operation of challenges or problems that has to do with logarithm. Okay, so we're going to look at about 9 of them. All right, now I made a promise in my previous video to give the laws, and here comes the log awaited promise. Okay, I know you must have come across some of these laws of logarithm and how to apply them, but I still want to bring that to your notice. Okay, so sit back as we go down into looking at these different laws of logarithm. So let's take the first law. Now, the first law of logarithm, I call that law the multiplication law. I call it the multiplication law. Multiplication law. What does it say? It says that if you have log x, y to the base of a, this is the same thing, or you split these two quantity to give you log x base a plus log y base a. Simple as ABC. That if you have a log, two numbers multiply themselves, then you add them to the same base. The two numbers will be to the same base. Or you have a heavy number, okay? You can split it, okay? Then now take it to the same base. That is what that law says. Very simple. Now let's take example to this law. Now, for instance, if you have example, if you have something like this, if you have log 30 base 6. Okay, now we are saying according to this law, we can split this 30 into two numbers or three numbers as the case may be. Okay, so we read this as log 30 base 6. That is how you read it. Or you can equally say log base 6 of 30. Okay, so if we are to split this, we know that 30 is the same thing as 6 times 5. So this will now become log, you can say bracket open, 5 times 6, close bracket, or to base 6. We now go ahead to apply the multiplication law. So if we apply this, this will now give us log 5 to the base of 6 plus log 6 to the base of 6. Very simple. Okay. We can as well go down to break this down because log 6 base 6, which is one of the rules, will give you 1. But just for the sake of simplification, I will stop here. Okay. So the log of 30 base 6 can equally be expressed based on the multiplication law as log 5 base 6 plus log 6 base 6. And that takes us to the next one, which is called the division law of logarithm. The division law. So number 2, law number 2, we call it the division law. Division law. And what does the division law of logarithm say? It said when you have two numbers dividing each other, okay, then you have a dividend and the divisor, then you subtract their log. In other words, if you have log x all over y, close bracket, base a, the law is telling us that you split this. So we are going to have log x base a minus log y base a. Very simple. Okay, very, very what? Simple. So if you have a division sign, what do? Subtract their log all to the same base. All right, so let's take an example to this effect. So if we take an example to this effect, let's proceed, or we take it from here. If we have something like log 100 all over 3 or into base 10. How do we simplify this? Let's move forward. Let's proceed from here. So how do we simplify this? This is what we do. According to the division law of logarithm, then this will now become log 100, which is the first one, base 10, then minus log 3 base 10. Wow, very simple. Now look at this log 100 base 10 can equally be simplified down. We can put in here 10 to the power of 2, move 2 back, then now it's going to give us log 10 base 10. Okay? But just for the sake of simplicity, just to prove this law, this is where I will stop this guy here now. Okay? By the time we look at all the rules, then we can go into solving that we now show that all this one can be broken down. But the bottom line or the idea of this is that when you have a division sign, then you subtract the log. Very simple as ABC. Then the next one, I call it the power law. The power law. Rule or law number 3. So I call it the power law. Power law of logarithm. The power law of logarithm says that if you have log n to the power of k base a, bring this power back. Okay, so if you bring this power back, multiply it by whatever you have here. So this is going to give you k log your n to the power of a. Anytime you have an expression of this kind, move the power backward, then multiply by the log. So to this effect, let's look at an example. For instance, what this law says is that if you have log 100, let's take this as an example, like log 100 base 10. This could be written, we can express 100 as log 10 to the power of 2 base 100. Very simple. Okay, because 10 to the power of 2 is 100. Now, according to this power law, move this guy backward. So if you move this guy back, this automatically will give us 2 log 10 base 10. Wow. And like I told you, log 10 base 10 will give us 1. But we don't want to simplify beyond this because we've not gotten to that law. Okay? For the sake of this example, we're stopping this here. So this expression is equally same as this. All right. The rule number 4, I call it the unit log. Okay? I call it the unit log. So here we have unit log. The unit law or the law of unit log says that if you have log 1, which is unity, 1 base a, this is equal to 0. Very simple. Log 1 base any number, whether base 100, whether base 1000, whether base an alphabet, is going to give you what? 0. From here, let's take an example. But before we take example, let's proceed from here. Okay, so example to the unit log is if you have log 1 base 25, this will give us 0. This is the unit log, okay? Unit log, because this is 1, which is unit, okay? So log of 1 base any number, whether alphabet or whatever, gives you 0. Then we proceed to the next law, which is what I call rule number 5. Rule number 5, call it the unity law. Unity law. Now, some of these terms or some of this name I gave them, I look at them critically and I decide to give them this name. You might not see them in other places, but it's in they are in confirmation with the rules here. The unity law says that if you have log x base x, so the log of any number base itself is equal to 1. Very simple. That's just the law. That's just the law. The log of any alphabet base itself is 1. The log of any numeral base itself is 1. So if we take an example to this effect, so let's see an example. We have here, let's say log 100 base 100 is equal to 1. As simple as ABC. Very, very simple. So that will lead us to another law, which I title law number 6. We have change of base. I call it change of base. Okay, what does it say? It says that when you have a particular base and you are not okay with the base, then you can change the base. So we have here, if you have log n base c, it means that I can change this base. And for me to change this base, I'm going to introduce another base. So this will now give me log n base, let's assume base b, okay, all over log c base this same b. So I have changed this base now to a different one, which is b here. Okay, so when you change the base, this will become a log on its own, and the base here will automatically become a log on its own to the new base you have changed to. Okay, like I told you, maybe the base you are working with is not covenant with the figure you have here. So what do? You introduce a base that is covenant to enable you break your log down. That is the excess of this. Let's take an example to this effect. Example, let's see how it works. Example, from here, let's proceed again. Let's take an example. For instance, if I have something like this, log x, y, base 9. All right. If I want to change this base, and I decide to change it to base 3, so this will now automatically give me log your x, y, base 3, which is the new base, all over log 9 base 3. Now, this is a product law again. So we can now apply product law. So we are having product law inside change of base law again. So if we are to simplify this will automatically give us here log x to the power of 3 plus log y to the power of 3, to base 3 rather. Okay, this is will now become log x to the base 3 plus log y base 3 all over log. Now, if I decide to put 3 here and raise it to 2, that will still give me 9. So 9 can also be written as log 3 to the power of 2 base 3. All right. Now, according to power law again if we bring this guy back, this will now automatically give us log x to the base of 3 plus log y to base 3 all over 2 log 3 base 3. Now we have already looked at the log to its own self base, which is the unity law. We cannot apply it here. So this will give us 1. So 1 times 2 will give us. So automatically, this expression will end up giving us 1 all over 2 bracket log x to base 3 plus log y to base 3. close bracket. So this is the final solution to this example given here. Very, very simple. All right, so let's go to rule number 7. Rule number 7. Rule number 7. So I call it the inverse law. The inverse law, or the reciprocal law. The reciprocal law. Okay. So what does it say? It says that if you have log x base a, now we can find the reciprocal of this to give us 1 all over your log. The a will become the log and your log will now become the base. So change of this base now. So this law is more or less same as the rule number 6. Okay, change of base and this reciprocal law, they are more or less the same. They are very similar. Okay, so that is for this. Very easy. They're straightforward. We go to rule number 8. I call it the base power law. I call it the base power law. The base power law. The base power law states that if you have log x to the base of a raised to power n, then this will now become 1 all over n log x base a. Very easy. What we'll say here is this. This is log x base a to power n. The base is carrying a power. Take this power back, then divide it by 1. So we have 1 all over n log x base a. Very easy. So let's proceed. Well, before we proceed, if you are new to this channel, kindly subscribe. Okay, and when you subscribe, turn on the bell notification button so that YouTube can notify you whenever we drop answer video like the one you are watching right now. Because in this channel, we drop new videos every day. All right, so let's proceed. Let's take an example to this. So we have here log 5 to 7 to the power of 2. We are saying that bring these 2 back. 1 all over these 2. So we have 1 all over 2 log 5 base 7. Okay, so from here now, you discover that we are going to have some challenge here. So we can apply the change of base law again. We can change this base to 5 or to 7 and, fire down or continue. Okay, all right. So the last one, which is not the least, we want to look at the relationship, which is number 9, relationship between indices and logarithms. There is a very strong relationship between indices and logarithm. Okay, for instance, if you have something of this kind in your indices form, so we have here a to the power of x equal to y. This is indices. Okay, so this expression, as it is in index form, how do we now write it in logarithm form? So this is log your y base a equal to x. Very simple as A, B, C. Okay, so these are the major laws that hold the foundation of logarithm operation. Okay, challenges that has to do with logarithm. With these laws, you can tackle the major challenges you have in logarithm. Now, I made a promise before now that I will produce this video. But now with this video produced, in my next video, I will produce a video, a clip on the proof to some of these laws. Though the proof might not that matter, but it's expected that you know some of the proofs. So I'm going to produce a video on how some of these laws are derived. the derivation of some of this law, the multiplication law, the division law, the quotient law, the power law, and the rest of them. Okay, I will make a video on that. But before then, let's make use of these laws in solving some of the logarithm operation we'll be looking at in some videos from now. Okay, remember, this is Online Maths TV, and my name is Jakes Anemo. I love you, and all of us at Online Maths TV love you too. Thanks for your time. See you some other time. Bye for now.